Good morning and good afternoon. Welcome to ARA's webinar Wednesday. I am Sri Rao, your moderator for today's webinar. The topic is understanding and predicting pavement performance in alternate delivery projects. Now I'd like to introduce our presenter, my friend and colleague, Mike Harrell. Mike is a vice president and principal engineer in ARA's transportation division. He has 25 years of experience in pavement evaluation, pavement and roadway design, asset management, and pavement rehabilitation techniques. He has extensive experience with mechanistic pavement design and life cycle cost analysis. And Mike has served many public-private partnership pursuits with teams and also design build teams and toll authorities and helped with pavement design and life cycle cost optimizations in these situations. Today's presentation is going to be really interesting for those of you who are interested in this topic of PPPs and design builds and so on. There's a lot of new information and constantly evolving information on this. So I'm really super excited to have Mike present today. Mike, thank you for presenting today, and I will hand it over to you.
All right. Thank you, Sri. Appreciate it. Good afternoon, good morning, good evening from wherever everybody's attending today and down the road on the recording. I'm pleased to be here to talk about alternate delivery projects and how pavements are impacted and can impact those projects. It's a topic that's near and dear to me. In my career, I've enjoyed working with those projects probably the most of any of the project types that I've worked on in my career. The interesting dynamics of working together with contractors, with the procurement specialists, with the owner agencies, with the financiers. It just really makes for exciting projects as much as infrastructure design projects can be. And what I've found over that time is how pavements can really impact and drive the decision process for a number of items in these types of alternate delivery projects. So really important to understand and predict how those pavements are going to perform over time, how they're going to support the goals and traffic flows that are expected and projected for each of those facilities. So today we're going to run through this outline. We'll start with some basic differences in procurement strategy, how we get to alternate delivery. What are some of the alternate project delivery types that are being procured? We'll talk about alternative technical concepts or ATCs. Then we'll go into upfront or background or base design case. We'll talk about long-term planning and then get into pavement type selection. And then we'll move on to optimization of pavement types. We'll talk about the differences between CapEx and OpEx, or capital expenditures and operational expenditures. We'll talk through related somewhat to CapEx and OpEx cash flow considerations, privatized maintenance, warranties, and finally a couple of slides discussing and describing Ashtaware's Pavement ME design software and how it can be used to help in these alternate delivery project type solutions. So here we go. Key differences really between design bid build and alternate delivery, and that's kind of where we start. Key difference really is that the general contractor involvement happens a lot sooner in a alternate delivery environment. Traditionally, design bid build has been the mode that most DOTs have worked in. The risk is primarily sitting with that owner agency in the design bid build environment. Follows those proven specifications and procedures, really encourages innovation through low bid procurement. So, there is still innovation in design bid build. Our contractors are always looking for ways to deliver projects as competitively as they can. And so they are incentivized basically to do that through low bid procurement. In alternative delivery, you get more opportunities for collaboration between the designers and the contractors, and really even the owner agencies. The risk can be shifted to the contractor. This can be sold as a benefit to taxpayers because the owner agency may not have to be responsible for something later down the road. Of course, that risk does translate to pricing, of course. And encourages innovation through the best value procurement. So not only low bid, but better schedule, better availability, potentially, innovative financing opportunities. There's a host of other benefits to those alternate delivery types. And so there are many alternate project delivery types. Starting out with probably one of the more basic ones is just considered design build. But then more recently, we've seen the advent and increase in uptake in progressive design build, which I personally have enjoyed a lot because that particular project delivery type has your contractor designer team selected based on qualifications with a much earlier interaction and really teaming environment with the owner agency. Public-private partnerships, where we start to see some private financing usually enter the picture. Then there's design, build, operate, maintain, and also design, build, finance, operate, maintain. So kind of permutations of design, build, and P3s. And then the last couple here, construction manager, general contractor, construction manager at risk. And the last one shown on the slide here, bridge and project bundling. As Shri mentioned during the intro, this is a kind of evolving area with many agencies trying to come up with the best solutions for procurement for infrastructure delivery. And so we may see many more types of these alternate project delivery types in the future. I do wholeheartedly agree that the FHWA Center for Innovative Finance Support is a great resource to provide definition and context for each of the alternate project delivery types, and will likely keep up with all of the ones that get added over time. Next topic for today is the discussion on alternative technical concepts, or ATCs. I've personally found these to be a lot of fun working in my career, and it's really one of the best opportunities for innovation. It is the idea that what is a concept offered by the competing team, delivering equal or better quality of finished product, and those ATCs are considered confidential. They're one-on-one, submitted to and discussed with an owner agency. An owner agency can accept them with modifications, or reject them outright. And one of the real benefits to it, which some of the competing teams may not really enjoy, is the concept that all ATCs become available to whoever is ultimately selected and awarded for the project. So it doesn't mean that one team can submit an idea that is approved for them, but ultimately left on the cutting room floor if they're not selected for the job. The owner agency gets to benefit from all of the ATCs that are submitted and ultimately approved, so that they get the best of what all of the contracting teams were trying to offer. I've got an example to describe. The Virginia DOT has some great language that they've offered on ATCs. It says they shall not consider proposed ATCs that include but are not limited to the following: a reduction in scope, long-term performance, quality, or reliability. They may not modify VDOT's programmatic risk allocation procedures, such as responsibility for utility location, responsibility for right-of-way acquisition, quality assurance, quality control program requirements, and minimum pavement section requirements, and impose an additional burden on VDOT for maintenance. So may perhaps requiring the purchase of specialized equipment. Additionally, VDOT shall not consider proposed changes to VDOT design standards and practices, such as those solely proposed for the purpose of relaxing a more stringent standard, unless VDOT determines that such proposed changes are directly associated with and required to implement an ATC for a unique design concept. All of that to say that they've put guidance and game rules around ATCs about which things are considered available for consideration and which ones should be categorically rejected and not pursued. And I will definitely say that each agency offers these types of guide rules early in their procurement processes, and they are ever evolving. Again, this is a dynamic industry that is, and so changes in specifications, changes in best practices are constantly taking place. So that is good to be mindful of what the guide rules are. Here's an example of an ATC process that I personally went through. I'm going to be scattering some examples throughout this briefing and webinar today of things that I've encountered in my career to kind of demonstrate some of the interesting things that have come along. The top left table represents a structural number calculation associated with an asphalt pavement design for a road in Tennessee. And it was considered to be the base design. And the ATC that that a project team developed was attempting to remove the requirement for including a cement treated base in the pavement design, and instead take advantage of more of the in place materials, or as many as they could, and substituting instead a lime stabilized soil to provide some more support for that pavement section. And so, back to the concept, ATCs must answer this question: does the concept deliver equal or better quality of finished product? And this example was showing how the contractor was innovating to use as much of the in situ base material as possible. Base design called for removal of an existing concrete pavement and the underlying granular base material, replacing all that with 8 inches of new aggregate base, of which the top 4 inches would be cement treated. Design build team proposed the ATC to instead windrow the existing aggregate base material, lime stabilize underlying subgrade soil, and replace the aggregate in place. And the solution would reduce haul off and import of material and provided a higher final structural number than the base design. So, just an example of ways to innovate with pavement design through the ATC process. So upfront or base design is really kind of where all these projects start. It truly does depend on the alternate delivery procurement at hand as to how far along the design is when it's handed over to the competition teams. In progressive design build, it may only go as far as about 10% concept design, because progressive design build is really intended to be a partnership between the owner agency and the contractor joint venture team. In a traditional design build, it may go all the way out to 30% design. In P3s, it can vary wildly from low percentage upfront concept designs all the way to more finished designs, anywhere in between. But those base designs really do align with the published project goals. So they will describe and declare the desired pavement design life. They will show and highlight how they can support the projected traffic loads and provide the desired capacity, typically described as number of lanes for that project. The table shown here on the right-hand side is an example from the Spaghetti Bowl Express interchange in Nevada, where you can see the different routes and road segments and what is intended with the base design for each of those road segments. The performance criteria can be established, and depending on the pavement type, there's opportunities to put in what those performance criteria are. If an initial design is not specified, an agency can instead develop the performance criteria against which alternate designs are compared. So they can say, well, rather than specifying that we're going to have a jointed plain concrete pavement for this infrastructure project, instead we'll allow the pursuit teams to offer their best solutions to pavement type and performance, with the guidance that these are the performance criteria that each pavement type would need to meet over the performance period of the project. And so oftentimes with upfront and base design, one of the biggest questions is to work to understand what is already there. Very few opportunities out there for greenfield design. Most projects are considered brownfield, which means that there is an existing infrastructure of some sort of pavement that's already there, and that typically needs to be increased in capacity or moved or realigned slightly to accommodate geometry changes associated with the increase in capacity, what have you. So the table shown here is an example from the I-15 Tech Corridor Improvement Project in Utah. Note the different pavement structures that are sometimes even in adjacent lanes. And so with the laser pointer engaged, we start at the top with mainline lanes showing a concrete pavement over a cement-treated base. The acceleration and deceleration and climbing lanes have an HMA section with an open graded surface course to provide additional frictional characteristics for those climbing and accelerating locations, with a underlying 9-inch hot mixed asphalt pavement, inside shoulders and HOV lanes, a slightly thinner section to show how most of these are not seeing as much truck traffic and therefore may not need as much structure. And then the southern end of that project showing a 5-inch hot mix asphalt pavement over a 9-inch original concrete that had been cracked and seeded over that 4-inch CTB. So very challenging sometimes to work with projects where the lanes are made of very different things. It really puts the emphasis on understanding what is there best to then project how to utilize as much of what is there going forward. So how do you do that? Well, there are lots of pavement tools to understand the current performance or quality of pavements. This is a slide that our company has used to describe pavement testing equipment fleet that ARA actually owns and operates. But many of these tools are the best in class for understanding current pavement performance. Falling weight deflectometers and heavyweight deflectometers for understanding structural capacity measurements and structural integrity. The LCMS and 3D Pass based digital survey vehicles for collecting distress information and right-of-way camera imagery for understanding how the roadway fits into the overall geometry of the corridor. High-speed profilers measuring the smoothness of the roadway, be it concrete or asphalt. friction testing devices to understand the frictional characteristics of current surfaces. Now, many of these projects do require resurfacing, but it's good to understand the frictional characteristics of the existing pavement and materials to have a good sense of how that may project into the future with a new surface of some sort. Ground penetrating radar is a great tool for looking under the hood, if you will, the non-destructive opportunity to get a sense of thicknesses of pavement materials that are in place, as well as whether or not voids might be present or moisture damage may be present, corrosion, even with bridge deck rebar and support. There's a host of ways to do a lot of non-destructive testing to gain data and information on what is currently there. And data helps drive great decisions. So we absolutely need to understand the best we can what is there today to best project then how we can work with it and make something valuable for the future. So this slide is an opportunity to describe also how the base design may highlight known design exceptions. And this allows for our designers to attempt to solve the problem or design including those exceptions. This drawing is an example from one of the segments of Interstate 69 in Indiana, which was a design, build, finance, operate, and maintain project. And what I wanted to point out here is not only do you get the cross sections shown along the alignment and how the thicknesses of materials may vary or not, and grades may vary or not, but in this case specifically, a discussion or shown here the mainline design exceptions that are present. In this case, a level 1 design exception where the proposed mainline inside shoulder is less than 12 feet wide, which did not meet their original requirement. And level 2 exception, how the existing equivalent length of grade exceeds the critical length of grade between two of the cross streets. And so it informs the pursuit teams on design exceptions that are currently present, offers them the opportunities to potentially solve those challenges, to remove the design exceptions, or to pursue further with the exceptions, and describe how the ultimate infrastructure alignment and design will still provide a safe travel environment, and how incorporating those design exceptions does not miss out on the opportunity to keep it safe. Now we'll talk a little bit about long-term planning. And really, this is, when you embark on an infrastructure procurement project, it is always good to have the long term in mind. Where is this project today and how are we making it better for the future? So what is the design life for that project? So specifically with regard to pavement, that can be declared to be 20 years, 30 years, 50 years, depends on the type of procurement and the ultimate goals of the owner agency. How much traffic is it going to support? Are there multi-use corridors that are being incorporated as part of that design? Sometimes there's right-of-way planned for public transit, be it bus or even rail systems. Sometimes bike lanes are being considered as part of the corridor enhancements. And then revenue projections, if that is part of a public-private partnership opportunity. And then specifically with regard to pavements, talking about the long-term planning, what is the ultimate desired capacity for a project? What kind of lane availability will ultimately be there, and what liquidated damages may be applied if lanes are not available for whatever reason. And that's part of the potential shifting of risk in some of those P3 environments where you see owner agencies say, one of our long-term goals for this project is to keep lanes open and available to traffic to move people and goods. And if the lanes aren't available, potentially because pavement has not performed in accordance with desired goals, then those lanes are no longer available and there may be liquidated damages associated with that lane availability. Also, talking to pavement-specific planning, a desire to minimize maintenance or rehabilitation closures. So kind of let's minimize the impact to the traveling public and reduce risk to those customers. The example list of sponsor goals shown here is from the Presidio Parkway design, build, finance, operate, maintain project from several years ago in San Francisco, where you can see how there was a description of the high-level goals for the project: improving mobility, improving operational safety, quantifiable air quality benefits. There's a number of ways to describe the long-term goals of the project. In a P3 environment, there are handback requirements after the maintenance period. These need to be taken into account with the final design strategy for whatever pavement is being designed for that project. How is the pavement going to perform during the performance period and still have remaining life at the time of handback? And the example shown here is a table from the procurement of the I-69 segment, design, build, finance, operate, maintain project, where you can see that there was a requirement that the pavement would have at least 10 years of residual life at the time of handback. So after the operation and maintenance period that the private concessionaire would undertake, that there would be at least 10 years before the owner agency would need to do something to restore service life to the pavement. And so that would, in order to ensure that at least a minimum of 10-year residual life, there was a requirement for inspections to take place, including up into the handback timeframe. And those inspections, as shown on this slide here, including automated condition distress surveys, ride quality measurements, skid resistance, rutting and faulting measurements, and that those should be reported on for each 10th mile performance section, and a guidance on how much of the overall project would need to exceed that projected residual life, understanding that maybe not all of it would, but no individual section having less than 5 years. So an allowance that maybe not all of it would be a perfect minimum of 10 years, but at least everything having at least 5, 90% greater than 10. And this is really just the agency understanding the risk calculation and economics associated with it, because this requirement absolutely puts risk onto the pursuit team, that public-private partnership, private operation and maintenance group. And so they, as an owner agency, may see a reduction in bid from that pursuit team associated with the risk that the pursuit team is taking on for the life at the end of the pavement. And so, this is something that all of these pursuits really take into account, is that exchange of risk for financing. All right, now we're going to move into pavement type selection. This is can be a hot topic associated with the continued great competition between our really two kind of primary pavement industries, being concrete and asphalt pavements. How do we get to the appropriate or best fit pavement type for a project? This process is often done in concert with a life cycle cost analysis, but may include other factors. And this NCHRP Report 703, the Guide for Pavement Type Selection, really does a great job of mapping the process for selecting the pavement type for a project. And it really goes through kind of these major steps, the identification of feasible alternatives. So you may reduce or eliminate some alternatives just because they're deemed to be not feasible for one reason or another. Then you'll develop pavement life cycle strategies. You'll get into a life cycle cost analysis of those strategies. If there are economic or non-economic factors, they can be evaluated and weighed accordingly. And then an agency-based selection of preferred pavement type can be done and also ultimately moved to the design bid build preferred pavement type. And really that is the typical or traditional agency-based pavement type selection process that results in a design bid build procurement. And the alternate delivery process can intercept this process to allow for different pavement types to be chosen based on the results of this selection process. If you do have non-economic factors, one of the ways that you can work that into the pavement type selection process is with the establishment of grade cards. And really, that's nothing more than almost, think of your grade report card that you would get going to school. Each criterion would get a letter grade. And in the example that I'm going to walk through here, this is from the Illinois Tollway procurement of one of their main corridors where they underwent a pavement type selection process that included both economic and non-economic factors. These were the factors that were being considered: the initial or upfront construction cost, the ongoing maintenance cost, a green or recycling factor associated with each of the pavement types, and a constructability and schedule factor. And the weighting factors associated with each of those criterion were determined through a panel of Illinois Tollway specialists and staff to really describe, what was most important to them for the ultimate, long-term goals of the project. And so when the pavement type selection was completed, the 5 options for pavement types are shown in each of the 4 main criteria that we just described. So construction costs, capital preservation, which is also considered to be operations maintenance cost, then a green or recycling component, and a constructability and schedule factor. And each of the pavement types had positives and negatives associated with different aspects of their construction. And you can see where, an A was given to the lowest construction cost associated with upfront. So in this case, full depth asphalt worked out to be lowest upfront. In capital preservation, then A grade was given to the lowest long-term preservation cost, and that was deemed to be with continuously reinforced concrete. Then on the green side, an A grade was given to the greenest alternative, and was based on criteria associated with the reuse of existing pavement or amount of recycling that was permitted. And this grade was a consensus from the engineering group with the tollway. And then the constructability and schedule factor: how quickly could the project be delivered? The west, middle, and east are actually portions of the corridor that was ultimately being constructed. So there was different challenges associated with geography along the corridor. You can see here where the schedule was challenging on the eastern end of the project, and it really had to do with the forecast of where asphalt could or may not be as efficiently delivered to a project. And so you can see where the letter grade had changed there. And so that was an interesting experience to go through with that pavement type selection. We'll move now to a discussion between CapEx and OpEx. So capital expenditures are your larger rehabilitation projects, milling, overlay, resurfacing, if you will, reconstruction if needed during the performance period. So depending on the length of time that your pavement is expected to be performing, you may or may not encounter the need to reconstruct it. Operational expenditures, more of your annual type repair strategies, like such smaller items as like crack sealing or joint spall repairs or small patching quantities. And so cash flow considerations associated with that, especially for P3 and toll facilities, in these cases, especially with P3s, the upfront bidder is the high bid. So contrary to typical procurement where low bid is considered to be the winning option, in the case of P3s, owner agencies are looking for the most return on their investment, and therefore the highest upfront bid is selected. And so the P3, in turn, would like to defer expenditures to recover that upfront cash outlay. So if you think about putting up a lot of money up front, really would like some time before you're having to put additional money into reinforcing or supporting that infrastructure. So how can the pavement designs accommodate that strategy? Well, you look for pavement solutions that have a lower CapEx upfront, so potentially doing work right at the beginning or just before the project were to take place, or how do you defer for some amount of time, still maintaining the performance requirements associated with that pavement, but gearing up really in recapturing cash flow to be ready for more construction to take place after the first, say, 10 years of that procurement timeframe. And so your life cycle cost analysis does a great job of kind of helping map out where CapEx and OpEx expenditures will take place depending on pavement type. And these are just some typical life cycle strategies associated with, say, a 50-year time horizon for jointed plain concrete, continuously reinforced concrete, or full depth asphalt. And you can see where there's targeted preservation opportunities based on pavement performance prediction for each of the pavement types, and then larger, more CapEx strategies associated with either an initial asphalt overlay or a subsequent mill and then overlay cycle in that pavement maintenance strategy. Whereas the full depth asphalt strategy, of course, having an initial construction requirement, but then a more regular mill and overlay cycle. This is typically associated with a pavement that would be considered a perpetual pavement, in where the overlays are really superficial, but the main bulk pavement structure stays in place for a longer period of time. So the preservation activities are more of, again, of those OpEx type activities, crack seals, surface treatments, diamond grinding, even some patching. But the overlays and the mill and overlay cycles are more significant and usually considered part of the CapEx strategy. And in life cycle cost analysis, you will see how this is all racked and stacked. They bring all the cost streams to the same dollar value, considering time value of money. Typically, they're presented as part of equivalent uniform annual cost or net present value. This option shows full depth hot mix asphalt as the lowest EUAC when factoring in initial construction and maintenance present worth. But if minimizing future maintenance is the desired goal, CRCP, or continuously reinforced concrete pavement, would be the choice. Typically, when you're doing a life cycle cost analysis, and this is agency dependent, but there is usually guidance somewhere in the neighborhood of 10 to even 15%, where if costs of alternatives are within 10 to 15% of one another, they're considered close enough or equivalent on the cost basis, and it allows the agency to ultimately select the choice that they would like. And for those that might be familiar with this project, I will say again, it's an example from the Illinois Tollway. Uh, Fun opportunity for people to maybe take a guess at which pavement design was ultimately selected for this project. And I'll give you a hint, it was not either of the ones shown in green, but is an example of where the EUAC for all of the alternatives was considered to be close enough that the agency was able to select which one ultimately was their choice going forward. We'll talk a little bit here about private and privatized maintenance. So, with regard to these infrastructure projects and P3s or design, build, operate, maintain projects, it removes that maintenance burden from the owner. And so the owner benefits from having a lower requirement for investment in personnel and equipment over time, and really pushes the accountability and assurance of quality standards onto that private maintenance group. And then the operator has an advantage, of course, associated with an increased revenue or bid value because they are looking to support the maintenance of those projects over time. And it may allow for innovations or efficiencies that the owner agency may not have been able to provide internally. So that private maintenance can sometimes allow for potentially increased or improved communications to the traveling public and optimize schedules to avoid traffic impacts. Lane availability and liquidated damages can motivate optimization on pavement performance and maintenance activities. And so shown here is actually an online calendar from the NTE Tex Express maintenance group, where the North Tarrant Expressway is being maintained in a number of segments. And so they show day by day the projections associated with where maintenance activities may be taking place to help the traveling public potentially change their routes or understand where delays may take place. Warranties. It's a more recent development, and really is becoming, I'd say, more and more accessible due to the confidence associated with future pavement performance prediction. So as we get better with predicting performance, we can feel more confident about offering warranties, or as an agency asking for a warranty to say, we expect this pavement to perform over a period of time, and we want you to stand by it. And so the right-hand bullet group comes actually from a 7-year warranty on an Indiana toll road project, where the owner agency wanted friction, IRI, rut measurement, PCR rating, longitudinal transverse cracking, and general distresses to all be warranted for 7 years after initial construction. And so that then played into the contractor's bid opportunity to understand how they might not only design but build their pavements so that they had the best chance of providing and exceeding these warranty requirements. So another innovative option there. And so I wanted to, last couple of slides here, talk a bit about the AstroWare Pavement ME design software. This, I feel very strongly about, one of the best tools for modeling pavement performance that I've ever seen. It's used in more than 40 states and over 20 international countries, and is being adopted more every day, which I love to see. It allows for custom inputs for infrastructure projects, where each site is has an opportunity to receive a design that is tailor made for it. Includes the opportunities to customize pavement materials, location specific climate files and data associated with that location, customizable traffic streams and volumes associated with that area of infrastructure, and performance targets. Like we talked about earlier. So really gives an opportunity to move, into the real 21st century of, hey, designs aren't just based on extrapolations from the ASHO road test, but really have taken advantage of more than 50 years of real valuable pavement research done by universities and consultants across the world to understand the pavement performance over time. And this just gives you an idea of how you can set up a project and input performance targets. You can run sensitivity analyses to understand the criticality of each of the variables that are part of your pavement solution that you're trying to provide. The software will then predict how much of each distress will accumulate and when it will happen. So in this case that's shown here on screen, the IRI is shown to fail before the 20-year design life. So if you see here the age, 20 years was determined to be the design life in question that we would analyze for. We are showing an accumulation of IRI beyond the acceptable target. All the rest of the structural and performance criteria are showing to pass. But in this case, the pavement strategy accompanying this design did meet the requirements because there was a targeted overlay as a handback requirement at year 12 of the 20 years. So the desired design here was a 20-year structural design with a minimum 12-year performance for the surface. And so this IRI was shown to be not meeting the full 20 years, but we'll see here that it actually did meet the 12-year requirement. One of the neat opportunities with Pavement ME design is an opportunity to check specific variables against base design criteria. And so what I've shown here is the initial IRI in the base design is the default value associated with Pavement ME design of 63 inches per mile. That's an aggregated average with contractor performance. However, the contractor that was pursuing the project that we're talking about was confident that they could deliver an initial smoothness of 50 inches per mile and was pledging and committing to that as part of their bid. And so the change associated with that initial IRI allowed for the base design would show IRI failing at year 10, which did not meet that handback requirement of an overlay at year 12. But the initial IRI of 50 inches per mile moved the time at which the IRI would exceed the performance criteria out to what was projected to be year 14 and a half. And so that meant that contractor would feel confident that they would get all 12 years of that performance before the targeted overlay with the structural pavement design that they provided. So by utilizing the contractor's quality data, it supported innovative design and paving smoother upfront. It bought them time to the next rehabilitation. My last slide for this is a shout out to Ashtoware, really to describe that there are a ton of videos on their site to describe really how to use their state-of-the-art tool, Pavement ME Design, and a number of modules. And I encourage anybody that is in this field that is not familiar with where these videos are and what they can provide, go out to the YouTube site and take a look at those modules or really get you up to speed on how to utilize Pavement ME to the best of yours and its abilities. And with that, I will turn it back over to Shri.
Thank you very much, Mike. That was a great presentation, and I enjoyed it a lot, and I learned a lot of new things, and I hope our participants did as well. We hope everyone enjoyed today's presentation and that you will join ARA on December 10th for Microbots for Healthcare and Environmental Remediation, presented by Dr. Louis William Rogoski, who's a senior scientist at ARA. You may now begin submitting your questions in the chat box, and Mike will answer as many questions as possible in the time that is remaining. Just as an FYI, we have many more exciting topics. We continue to solicit speakers and continue to add topics for this year and next year. So please watch your email for updates or visit the Webinar Wednesday webpage, www.ara.com/webinars to make sure you register and sign up for our monthly webinars. So let's get to the Q&A portion. I see there's a few questions that have been sent to us, and I'm going to kind of ask them, Mike, in a few minutes that are remaining. So can you talk a little bit about, you mentioned the opportunity for innovation. What do you see as some of the innovative things that are going on in terms of materials for alternate delivery?
Great question. I think agencies, just tend to be very conservative and deliberate in their approaches to incorporating and accommodating newer materials. They want to say, prove it, and we want to know that it's going to work before we incorporate it as part of our specifications. So there are often opportunities in some of these alternate delivery projects where the pursuit teams may offer inclusions of, say, fiber reinforced asphalt, or the inclusion of geogrids, regressed or balanced asphalt mix designs, better use of in situ materials, so leaving what is there and using it as part of the structure. We'll see a lot of creative solutions from the alternate delivery pursuit teams brought to the table. Not to say that our owner agencies aren't interested in those as well, but sometimes their procurement processes may tie their hands and not allow for as much creativity. So the alternate delivery format is a great opportunity there.
Well, thank you for that answer, Mike. There's a few questions that asked about sharing the PowerPoint, and I just wanted to address that. We will share the PowerPoint. Give us a few weeks, and we'll send an email with the certificate of attendance, and that will include the PowerPoint as well. So that's something. Just watch your email for that. There's a question that I don't fully understand, so I'm just going to throw it out there, Mike. Masood asks, any updates on the user cost program used for LCCA? I'm not really sure which program Masood is referring to. But
my guess is that, Shri, I think that might be the FHWA's real
cost.
Yeah, likely real cost, and the user cost portion of it, which is difficult in a word. It does take some practice to work with, and there are some agencies that incorporate the portion of real cost with regard to user cost. Others have declared that they don't necessarily understand how that is as beneficial as it could be. I think we're still trying to understand how to get good data into the user cost component to really support that decision.
Okay, I'm glad you understood that question.
No problem.
There's a question from Rob who's asking what considerations are made during evaluation of concrete pavement options for setting up an on-site batch plant.
I would say that's a combination of available real estate, environmental considerations, and permitting, availability and proximity to material. Yeah, that's a tough question. That's definitely one that's site specific.
So Hila is asking, how do you capture the risk with JPCP that is 60 years old and needs to last another 50 years based on the term of the concession? The pavement shows both structurally and visually is in good shape. I know this is a little specific, Mike, but I don't know if you want to talk a little bit in general in terms of
Yes.
risk at the end of the life.
Yeah, sure. No, that is a very common scenario in these in a lot of large infrastructure delivery projects because you're needing to replace a very valuable corridor that has likely been in place for a long time. So there are a number of alternatives for using as much of that existing pavement in the new structure. I think we've described that we won't get into consulting answers per se during these webinars, but there is ways to keep that concrete pavement in place to support structure going forward with confidence that it will last the 50-year performance requirement.
Okay, thank you. We'll end with one last question, Mike, and then I'll wrap this up. Mike is asking, I didn't understand the part about accepting the high bid rather than the low bid. Can you clarify how that works?
I sure can. So that environment is really about public-private partnerships or private financing, and where an owner agency is putting out a project, their goal as the owner is to receive the highest bid from the P3 consortium that would then lease or operate that infrastructure for a period of time, and the P3 consortium would then typically receive toll revenues on those projects to and they have to do their own calculus on how much money they pay the owner agency up front versus how much they expect to capture over time, given traffic projections, toll increase allowances over time, revenue projections. But the owner agency is really looking for the highest bid in that environment.
Yeah, and just to clarify, Mike, I think you mean that it's not necessarily per mile. It's just what the value that they're getting at that point in time in terms of the different bits, correct?
Yes, exactly right. Yes, thanks, Sri.
We have a few more minutes, but if we didn't get to your question, our presenter has agreed to answer questions for the next 24 hours via email. We just ask you to make sure that your questions are not of the consulting nature, that you understand due to the sensitivity of the topic. Responses may be limited. On behalf of ARA, thank you again for joining us today. Today's presentation is being recorded, and a link will be made available on the ARA Webinar Wednesday website early next week. And we will also send a PDA certificate to all participants verified by our attendance report as present for the full hour of the webinar. A copy of today's presentation will also be included. Please allow at least 3 weeks to receive your certificate. I always end with this slide. So ARA is a great company to work for, and it's very unique in that it's 100% employee owned. We continue to grow dynamically and are always looking for great people to join our team. So if you're interested in employment opportunities with ARA's transportation and infrastructure offices, please send a brief resume and contact information to www.joinara@ara.com. Thank you for joining today.